Alright, here we go with 8.4 and 8.5 homework. So 8.4, center of mass, things like that. So you just got to read these questions carefully and slowly. At least that's what I found works best for me. Point mass of 2 grams is located 3 centimeters to the left of the origin. Okay, so, oops. So I'm going to draw a number line here. And here's the origin. So 3 centimeters to the left is 2 grams of mass. Point mass 5 grams is located 4 to the right. And what else? And they're connected by a thin light rod. So when they say thin light rod, we mean it's massless, unless they give you information on it. Find the center of a mass of the system. Let's see, so center of mass, which we call x bar, is the sum of the moments divided by the sum of the masses. It's going to be that balance point, wherever that might be. And since this 5 is so much heavier, I suspect it's going to be over here somewhere. So I want to find the moments. In other words, the weighted average is kind of another way to think of it. It's the location times the mass, so this would be negative 3 times 2 plus the location 4 times 5 all over the total, the sum of the masses, MSI, should be 7, so that would be negative 6 plus 9. If I could do this right, I can't multiply. I'm looking at my thing going, that's not 9, that's 20, sorry. So that'd be 14 over 7, which is 2. Okay, this is the position where the center of mass is. So it's that weighted average, if you will. Okay, so if this is my balance point, it would balance right at 2. Okay, number 9. Number 9 is we go 3-dimensional here. So center of mass of a block. We've got an x, y, and z axis. So I'm going to draw it like this. And I'll put z going up here. So I've got this block that's 10 units this way. It comes out 3 and it goes up in my z direction 1 unit. Okay, and it tells me that the density delta is 2 minus z for 0 less than or equal to z less than or equal to 1. Well, by telling me the density depends on z, that means you tell me a z value, which is a height value, then this formula tells me what the density is. So at any z, see if I can get a different color here, which probably can't see it because it's behind my little screen thing, or behind my marker that you can't see, so we'll just go with this. So at any height z across this rectangle right here, which I'll shade it in here, that rectangular slab, if you will, that has a constant density. Okay, so the mass of that object, which is what we're trying to find, the mass of that slab right there, or mass of the slice, is equal to the density at some height x times, well, that's the density is, what do we have to look at my units here? They don't have units, but it's the mass divided by the volume. Well, what's the volume of this thing? Well, that slice is delta z thick, so it's going to be times 10 times 3 times delta x. Alright, the width base times the height times delta z, sorry. Hope I don't make too many of these little mistakes. It's late Saturday night. I wanted to get this done here for you. So this becomes 2 minus z times 30 times delta z. So then the mass of the whole thing, if I want to add up all those slices, the total mass would be the integral from 0 to 1 of 2 minus z times 30 dz. Okay, and I'm not going to do all these integrals, but I'll do some of them. In fact, this one I'm not going to do because it is pretty straightforward. So if you do that, you will get 45. We don't have units, so 45 grams or whatever it might be. Okay, makes sense? All right. I say makes sense, and if it does or doesn't, you can't do anything about it. But let me know in class if it doesn't.